So welcome to this Unconventional Machining Process course, and the course code is ME8073, and it is a professional elective 2 subject for the regulation 2017 for the mechanical engineering students. So here in this video session, we'll be studying about recent trends in non-traditional machining process, Unit 5, and in which first we will go in detail about the syllabus of the 5th unit. So the main objective of studying this unconventional machining process is to learn about the various machining processes involved here and the various process parameters and their influence on performance and their applications. And the syllabus, you have recent developments in non-traditional machining processes, the working principles, equipments, and effect of process parameters, applications, advantages and limitations, and comparison of non-traditional machining processes. So these are all the textbooks and reference books for this unconventional machining process course. So the course outcomes for this course, unconventional machining process, is the students will be able to explain the need for unconventional machining processes and its various classification after completion of Unit 1. And after completion of Unit 2, the students will be able to compare various thermal energy and electrical energy based unconventional machining process. The students will be able to summarize various chemical and electrochemical energy based unconventional machining processes from Unit 3, and from Unit 4 the students will be able to explain various nano abrasives based unconventional machining processes, and from Unit 5 the students will be able to distinguish various recent trends based unconventional machining processes. So introduction to recent trends in non-traditional machining processes. So the new trends for machining. Normally the machining process is very important in the productive activity, both directly for the manufacturing of components and indirectly for the manufacture of auxiliary elements like tools and tools for the manufacture of components by other injection processes. So the technology related to machining has evolved a lot in recent years, with improvement that affect multiple fields like cutting tools, machining technology, means of production, CAD/CAM or sensors. However, there is still room for improvement in machining processes by using various new technologies and optimization based on the knowledge, greater knowledge of the processes. So here the most prominent areas of work in the field of unconventional machining process are laser beam machining and ultrasonic machining and electrochemical machining. So in this video session, we'll be studying about the ultrasonic machining principles, its applications, advantages, disadvantages. So the principle of ultrasonic machining. So here in the ultrasonic machining process, the material is removed by microchipping or erosion with abrasive particles. So you can see from this ultrasonic machining machine setup, you have an ultrasonic transducer, and you have a transducer cone or that is being connected to the connecting body, and you have a tool header, and this tool header below you have this cutting tool, and that is you have this abrasive slurry is there in below that, and the workpiece is placed on the fixture above the table, and the tool movement, that is the cutting tool, is the reciprocating movement, and here you have a reservoir with the abrasive slurry, and you have a circulating pump which circulates this abrasive slurry into the in between this cutting tool and the workpiece, and you have an ultrasonic oscillator here, and this ultrasonic transducers will transduce this reciprocating motion. So here this In this machining process, the material is removed by this microchipping or erosion with the abrasive particles. So this tool would force the abrasive grades in the gap between the tool and the workpiece that would impact normally and successfully on the work surface, thereby machining the work surface. So in ultrasonic machining process, the tool made of a softer material than that of the workpiece is oscillated by the booster and sonotrode at a frequency of about 20 kilohertz with an amplitude of about 25.4. So coming to the applications of ultrasonic machining, this ultrasonic machining is used for machining of hard and brittle material like ceramics, boron, carbide, titanium carbide. And this ultrasonic machining enables even a dentist to drill a hole of any shape on teeth painlessly. And advantages of ultrasonic machining: so non-conductive materials can be machined, and there's no any change in microstructures, physical or chemical properties, and surface finishes betterly, and higher structure integrity is there, and the operation is noiseless. So workpiece harder than 60 HRC like carbide ceramics can be machined by this ultrasonic machining. And this also has its disadvantages. So low metal rate removal and this high power consumption. Cost of the tool is high and it wears rapidly and not suitable for soft materials. So with this, we come to an end with this video session for this ultrasonic machining of Unit 5. So thank you and have a great day.